world outside our classrooms is changing at an unprecedented rate. The exponential growth of information and technology leaves little doubt that school is no longer the exclusive or even primary method for acquiring knowledge. Educating young people to deal with a rapidly changing world means they also need to learn how to manage a range of information and challenge that we cannot begin to imagine. It will not be sufficient to know facts and ideas. Young people will need to be able to decipher what they need to know and how to use that information. They will need to be agile lifelong learners, able to adapt to new situations, challenges, and careers. Key problem solving and critical thinking skills and competencies must be included in every student's education. A well-crafted engineering design challenge lays out a basic need that must be met or a challenge that needs a solution. Instead of saying, build a bridge using these materials and designing it to hold a certain amount of weight, a better challenge would be to design a way to cross a hypothetical river safely while efficiently using resources available locally. That creates a scenario where students envision a unique end user, perhaps even a place, and design to meet those needs and criteria. While there is a process involved in engineering design, we at Project Engine urge you to resist attempts to have students memorize or even follow steps in a prescriptive manner. Every challenge is different, and there are often multiple entry points. The engineering design process is almost always iterative, and backtracking to previous steps often provides valuable insights and modifications. It should function like a framework, not a rigid algorithm. And our goal is to move our classroom from a place where the focus is on finding the one right answer to a space where multiple solutions are possible. It helps to think of engineering design as a natural problem-solving process first. When using it to frame a project in the classroom, think of it as having 3 phases. Know your problem, know your options, and develop a solution. Always be sure that you and your students have a clear understanding of what the core problem or challenge is. Ask questions, look for cause and effect relationships, and identify impacts. Engineering design challenges are generally ill-defined problems, but they are not undefined problems. They are real problems with many possible solutions. In our experience, many educators and students struggle with managing the design process because of a failure to clearly identify and evaluate constraints and criteria, and relate design decisions back to them. Together, constraints and criteria frame the design space. They help to bring some needed definition to an ill-defined problem. Part of the art of good problem definition is to have just the right amount of constraints and criteria. Too few can make design an overwhelming moving target, and making it difficult to even come close to solving a problem. Know your options. Brainstorm to go big. This is the part of the engineering design process that may challenge all the tools in your toolbox. It is also the part that makes design a truly robust process that brings creativity and innovation into your classroom practice and culture. So please do not skip it. A lot of time during our workshops are devoted to fostering creative and divergent thinking strategies and activities because they are far from the norm in most classrooms, particularly as students get older. Many students will not be comfortable in the wide open spaces needed for divergent thinking, and many will want to get directly to building, which is more concrete and seems more defined to them. Many great discoveries start out as crazy ideas. As a leader, you also need to stress, model, and honor the idea that all ideas need to be respected and that there are no bad ideas. This phase is all about quantity over quality, simply because new ideas cannot be evaluated until they are out there. Lots of crazy is good. Students and teachers new to engineering design often get a bit hung up on the idea that a prototype needs to be fully functional or a totally accurate scaled-down version of a product. They are simply ways to visualize and hopefully test ideas for feedback and perhaps some ability to function. In education speak, think of prototypes as formative assessments. Just as formative assessments should be used to modify and adjust learning experiences, prototypes should be used to modify the planned final product. They should be indicators of what works, what needs improvement, and how close student solutions are coming to addressing needs and meeting constraints and criteria. Maybe most importantly, prototypes allow designers to check for user interaction as well as function. Bring the real world into your classroom. It needs to be there because the students you are teaching today are our future. They will be faced with developing solutions to a wide range of problems and designing technologies that will improve our lives and safeguard the planet. They will have to make decisions about products, processes, and situations we cannot begin to imagine. They will need to be innovative, entrepreneurial, and able to adapt in order to be productive and happy members of society. We know the world is changing rapidly, and education is struggling to keep up. As a teacher, you can take steps to close the gap between the world in your classroom and the world outside. Connect concepts, embed skills, and model the process of creative problem solving with engineering design. Remember, you don't teach a class, you teach young people. Making a difference starts with how you impact them. It starts with providing them with engaging and empowering projects that give them the confidence and skills to engineer a better world. Let us be the catalyst for a transformative shift in teaching and learning at your school or district. Explore our website to learn more.